Warning. This Conlang contains many high-pitched noises and sounds that may sound like sirens. If any of the people viewing this may be sensitive to such noises, I recommend that you click away. Hello and welcome to... or in English, Grapherit, a submission for Agma Schwa's cursed Conlang Circus. Grapherit is a language based off of Desmos, an online graphing calculator, which allows you to make graphs of varying levels of complexity. Desmos also has a helpful function called tone, which plays a specific tone for a number's frequency. This function is the basis of Grapherit. In Grapherit, all words are different functions, and clauses and sentences are made up of different functions played simultaneously. In short, a sentence in Grapherit is made up of a series of overlapping tones, each representing a specific word in that sentence. So a sentence may sound like this. The average adult human can hear sounds from around 20 Hz to around 20,000 Hz. However, sounds above 1,500 Hz basically just sound like a high-pitched whine. For this reason, I decided to limit all functions to 1,000 Hz. There were a couple ways that I could have done this, but I thought it would be cool to make the function bounce every time it reached its limit, like you can see in this graph. To do this, I run all words through this bounce function. Thanks, Reddit! Now that we know how the sound works, we can make words. All words are polynomials of different degrees, and their degrees are decided based on the part of speech, or lexical category, of the word. For those of you who don't know, a polynomial is an expression composed of coefficients and variables raised to different exponents. The highest exponent of a term in a polynomial is known as the degree of the polynomial, and that's what we care about when making our words. In Grapherit, all lexical categories are connected with a certain degree of polynomial. Conjunctions have degree 0, pronouns have degree 1, prepositions have degree 2, interjections have degree 3, adjectives and adverbs have degree 4, verbs have degree 5, and nouns have degree 6. So, for example, all verbs are polynomials with a degree of 5. Verb tenses are determined with transformations of the graph of the word. I will show examples on the screen with the verb to be. Past perfect uses floor, past simple uses square root, habitual uses sine, present simple just uses the base form, and future simple uses mod 600. All of the tenses don't use the exact functions that I listed, but modified versions that make them sound better for the language. Plurals are quite easy to make in Grapherit, as you simply multiply the function by the number of items. So this function is thing, and this one is 3 things. When the plural is not mentioned, like in some things, you multiply the function by a non-integer constant, which is dependent on the amount. For very few things, you multiply by 0.5. For a couple things, you multiply by 1.5. For a lot of things, you multiply by 3.5. For a whole lot of things, you multiply by 5.5. While cardinal numbers, numbers for amounts like 1, 2, and 3, are made through multiplying functions by a constant, ordinal numbers, numbers for the order of a list, like first, second, and third, are made a little bit differently. Ordinal numbers are made by combining the word for the number with the word order. But how do we get the word for the number? We, as humans, use base 10 due to us having 10 fingers. Meanwhile, speakers of Grapherit use base -2 due to the fact that they have -2 fingers. This means that each digit in their numbers are a power of -2. The first digit is worth 1, then -2, then 4, then -8, and so on. These are the first 30 numbers in base -2. Please don't ask how long I spent on making them. Each digit is represented by a line at a multiple of 200, where each new line up is a new digit. If a line is there, it represents a 1, and if it is not, it represents a 0. In order to negate a word, you put it on the bottom of a rational function. Basically, what we do is we divide 1 by the function, with some dilation to make it look nice. This isn't just used to negate words, however. It can be also used to make opposites. For example, this transformation, used on the word day, makes the word night. If I want to change a word's lexical category, I need to change its polynomial's degree. An easy way to do this is to use the mathematical functions of derivative and indefinite integral. Don't worry, you don't need to know what these functions do mathematically. All you need to know is that they can change a polynomial's degree. The derivative will bring the degree of a polynomial down by 1, and the indefinite integral will bring it up by 1. So, for example, if I need to turn a noun into a verb, I would take the derivative of the noun. This may seem useless for now, but don't worry, it'll be important later. Now, you may remember that at the start I said that all words in a phrase are played simultaneously, and you may be wondering how word order works. Well, to tell you the truth, I lied earlier. I said that the tone function only takes one number, when in actuality it can take two, the frequency and the decibel level. You can give any number between 0 and 1, 1 being full volume and 0 being muted. We can use this to differentiate between syntactic roles. I don't know if that's the right term in English, but we'll roll with it. So, the subject of a sentence will be at 0.7, the predicate will be at 0.8, the object will be at 0.85, descriptors, like phrases, adjectives, and adverbs, will be at 0.2, and connectors will be at 0.3. Due to Grapherit's relatively small vocabulary, many words are made up of multiple words put together. Now, a major problem with this idea in Grapherit is that we have no order to the words. We wouldn't be able to differentiate between a race car and a car race. In order to solve this, we can increment the decibel level by 0.01 for each new word. On top of this, in order to create a compound, all words need to be in the same lexical class. I told you it would be important. So, to create the word bird, we can combine the word fly, but as a noun, and animal, incrementing the decibel level by 0.01 for each word, eventually getting the word bird. This also happens to be how you make nouns possessive. So if I had the word name and then the word me, it would be my name. The domain of the sentence, to which x values the graph goes to, is determined by the type and the truthfulness of a sentence. The types are question, opinion, known truth, speculative fact, and idiom/saying. The matching domains to all of these sentences are shown on screen. Regarding the translation, there'll be a literal translation of the sentences with a word order to make it easy to read. But just remember that all of the words are being spoken simultaneously. I'm also using some glossing terms, but only when I feel like it, because I'm too lazy to actually learn glossing. Anyway, let's begin. Well, that's it. Thank you very much for watching, and I hope you enjoyed.